Comment 1225 gives you one of two ways to determine the nature of a stationary point. The other way is using the second derivative, but that's a matter for another video. Comment 1225 is just about the basic way, which is to do a derivative table. So not an XY table that would tell you how high points are for an ordinary graph, but a derivative table which tells you whether things are going up, going down, or flat. So let's say you found a stationary point of 3. And because it's a stationary point, dy dx has to be equal to 0. In fact, that's probably where x came from. Now, what you do to determine the nature of this stationary point is to take two neighbours. So you could go 2.9, 3.1, or 2, 4, or 2.5, 3.5. You just have to make your own judgment on how close these need to be in order to get a good sense of what is going on. If there was another stationary point in the same picture that was super close to it, then that would be dangerous. I would now go 2.9 and 3.1, so that I can go 2.6 and 2.4 for this 2.5 one here. So what you do is you then substitute into the derivative. So let's say the derivative was I don't know, 3 minus x. So you sub 3 into that, of course you get 0. Sub 2.9 into it, of course you get you get 0.1. If you sub 3.1 to it, you get negative 0.1. And so what you do is just draw a picture showing that that's flat, that's going up because the gradient is positive, that's going down. And then you say, therefore, it's a local maximum. For this one, let's say it's a different example. So dy dx equals 2.5 minus x all squared. Let's say that's your derivative. So 2.5 gives 0, obviously. 2.4, that'll be 0.1 squared, so that'll be positive. That'll be negative 0.1 squared, so that'll be positive as well. So in other words, you're going up, flat, and up. And then you'll say that that is a point of inflection, but that's a matter for another video. But what you're basically establishing is there that it's not a local maximum or a local minimum. Now, the other possibility, I'll tell you what a local minimum looks like. It's when your table of values is 0, negative number, then positive number. So that's down, flat, up. That's what a local minimum looks like.